the field of in the field of plus q charge. In the field of plus q charge, what we did, we worked on a small charge and we tried to bring that charge inside. Then what happened? When we try to bring that inside, there was a, see, we are working against the, we are working against the force, because this plus q charge, he will try to push that unit positive charge because they both are positive. But we are working against the force now. So there will be a storage of energy, and that storage of energy will be known as what? That storage of energy will be known as, yes, that will be known as potential energy. See, before also the potential energy, how we got potential energy? By simply finding the work done. Here also, what we will do, will find the work done and we'll get the potential energy. We'll find the work done and we'll get the potential. Okay, so what is the basic, how we can find potential? By just simply calculating this work done. Okay, so let's move further. What we have a small derivation. Let's start with the derivation. In this derivation, what we have unit positive charge. We have a unit positive charge and the main charge. This is the unit positive charge. This is the main charge. Now, what I'll do, I'll try to bring this charge inside the field somewhere at point P. Somewhere at point P. Then what will happen? Yes, I had worked externally. That means external force had been applied. There is a displacement. Let us take that this is your R. This is your R. How we can find the potential? We have to work on the formula for the work done. What is work done? Simply the work done is, yes, force into displacement, right? So here also we have force into the displacement. Let us consider the displacement is very small. This will be FDR. Okay. Force is a vector quantity. Even displacement is a vector quantity. Now, as the force is increasing, while we are trying to bring this inside, the force which will be exerted by Q will be variable. As the force is variable, we are going to use the integration sign. Acha, what is force? We have studied in the last chapter. Yes, we have studied in electric charges and field. What is force? Force is E times Q. Yes, force is E times Q. So this will be equal to what? This will be equal to, yes, E Q dI. We have to write the limits. So limit will be what? It tries to come from where? It tries to come from infinity. It can go till distance r. So I will write integration of from infinity to r. Now, as this Garuda is a unit charge, I can write in place of q, I can write 1. Yes, you can write 1 and you can solve further, but still it is 1 coulomb only. You can write 1 coulomb and you can eliminate this thing, but further I am not eliminating it. If you want, you can do it. So what we can do, we can write the formula for E. What is E? What is E? What's the formula for E? Yes, E is K, our constant, Q, main charge, upon yes, upon r square into Q dr, right? K Q upon r square into Q dr. Done. Now what? Now I can, and we have integration. Integration will be from infinity to r. We have constant. Yes, we have constant. K is constant. Yes, K is constant. Q is constant. Yes, Q is constant. R is constant. Yeah, this small q is constant. Yes, small q is constant. R is constant. No, no. R is not constant. So what we can write? We can write is equal to integration of is equal to integration of, we can write this will be equal to, this will be equal to integration of, sorry, this will be equal to K constant out, Q constant out, Q constant out, integration of what? It will be integration of 1 over r square dr. So this will be equal to, this will be equal to K, I'm writing it again, Q, Q integration of 1 over r square dr, and limits will lie from r to infinity. Now what? K, Q, Q integration of r raised to minus 2 dr, and limit will lie from r till infinity. Integration of r raised to minus 2 will be what? Yes, we have integration standard formula. That standard formula for integration is in the marker. Yes, the standard formula for integration is integration of x raised to n is x raised to n plus 1 upon n plus 1. So the same integrating formula I will use here. So what I will get, I'll get this will be equal to k q q multiplied by what will be r square integration n plus 1. What is n? Minus 2 plus 1. So what is minus 2 plus 1? Yes, it is minus 1. So what I will get? I will get r raised to minus 1. Then I'll apply the limit. Upper limit will be infinity and our lower limit will be r. So this will be equal to k q q. R inverse is 1 upon r. First I will write 1 upon r minus 1 upon infinity. What is 1 upon infinity? Yes, it is 0. So what will be the value of work done? Our value of work done will be k q q upon r. Our value of work done will be k q over r. Okay, so I am writing the formula. Our formula for work done, this will be equal to k q q over r. Okay, this will be our formula, which we will be deriving in this thing. And what is this work done? This work done is nothing but you're the same. What is the same? That is our, yes, that is our potential. What is potential? V. Okay, so this work done will be stored in the form of potential energy, and that can be given by V. So this will be equal to KQQ per unit time. Okay, let's see some numericals based on this. Yes, one interesting question from this topic. We have some. Yes, the question is, what is the relationship between electrostatic potential at a distance r from a point charge q? What is the formula for electrostatic potential? And what would be the right answer? The options are 1 over r, 1 over r square, or t. I repeat, what is the relationship between electrostatic potential at a distance r from a point charge q? Options are 1 over r, 1 over r square, only r square, or r. Option C. Someone is giving answer option C. Anyone else? Anyone else? Option C. Let's see what's the formula for electrostatic potential. What's the formula for the electrostatic potential? The formula is the formula for electrostatic potential is V equals to K, yes, Q over R. Constant, constant. That means what? V is inversely proportional to R. That means our option A will be the right answer. Okay, option A will be the right answer. Let's move to the next question. Electric potential is which quantity? Options are scalar, vector, both A and B, or none of these. Electric potential is which quantity? Anyone? A. Scalar. Yes, it is a scalar quantity. Okay.